Given an NFA, we are going to construct a regular grammar. NFA, okay, hereafter I won't allow anyone to enter the class. Now, today's topic, right? An NFA will be provided to us, and then what we are going to do is we are going to construct a regular grammar. We are going to construct a regular grammar. And then yesterday itself, I have told it. Yesterday itself, I have told it regular grammars are nothing but either right linear or left linear. You could not mix both. Either if you want to construct a regular grammar with right linear uniformity, you can do it so, or else left linear. You cannot mix both. Yesterday itself, I have mentioned. Now, what is this? Now, let me consider.
Ma'am, your screen is not present.
Okay. Wait. I forgot to share it. Okay. For today's class, right, we are going to construct a regular grammar from a given NFA. And then if I didn't mention NFA with epsilon or without epsilon, then it means it's without epsilon. Okay, for NFA with epsilon, we have to mention specifically. Now let me, as per the definition of the machine, right? Let me consider aim. Let me represent aim. This is state, transition function, set of final state. This is the regular grammar. Now for convenient purpose, right, let me construct a regular grammar of right linear form. Right linear form. If you want, you can take for left linear also. It's fine. But right linear also, nothing wrong in that one. So I'm choosing right linear. And then as we know the definition of grammar. Let me represent G, and then this is going to be the grammar for regular language. Let me use RL, grammar for regular language. And then from the mathematical definition of the grammar, right, it is N, T, P, S. I've already told N is the finite set of non-terminal, T is the finite set of terminals, P is the production, S is the start symbol. Now our target, this is our target. Okay, our target is to construct regular grammar from a given NFA. And then I have already assumed that we are going to assume whatever the grammar we are going to construct, right, it's going to be in right linear form. This is my assumption. So in exam, you should not write regular grammar as it is. Which one you're going to choose, whether the right linear form or the left linear form, please mention specifically. So that is the request from my side to you guys, okay? And once you're used to it, in future you cannot, no need to mentioning for right linear or left linear, because by checking the production itself, we'll be knowing whether it's right linear or left linear. But please, for my class, in my exam and all, please do mention whether right linear or left linear. Now, if I want to construct this grammar, then I need to know this, what will be the N, what will be the T, what will be production, what will be the start symbol. Now, N, right, and from the given machine, N will be nothing but set of states. So whatever the state, like in the case of NFA, we are going to have I don't know what will be the contain symbols, whatever the arcs, and also many states we're going to have. All these states, right, in the NFA, we're going to consider as the non-terminal. That's why capital Q, right, will be considered as the non-terminal for this grammar. This is Q from the given M and FA. Okay, whatever the states you have in the machine, right, that will be considered as the non-terminal in the case of the regular grammar to be constructed. And then next one is terminal. Terminal we need. So terminal, right? What we are going to consider is, so in my case, whether I might be considering 0, comma 1, so 0, comma 1, 1, 0 like that. So whatever this values, right, I'll be considering a terminal for this regular grammar. So these values are being indicated by summation. So let me consider T is equal to summation. This is also from the given machine NFA. Okay. Now, and then I have already told for machine also we have initial state. Likewise, in the grammar also we have a start symbol. So start symbol in our case, Q, definitely will be Q naught of the machine. Okay. For machine, if you're going to check for acceptability of a given string of a language, you have to start from the initial state. Likewise, for the string generation or the language checking things, whatever to be done in the case of grammar, right? It has to start from the start symbol. So start symbol also I'm considering an equivalent with initial state. This is also from the given NFA. Okay. Now the main problem, I mean, what to say, the main part of construction of a given NFA is the production. Example, what we I didn't mention specifically about this particular transition function. So transition function will be, depending on this transition function, will be constructing the production of this regular grammar. Now, let me write P will be constructed. P will be constructed from the transition function of the NFA and and the rules the rules are, let me write the rules, but don't get confused. I'll be taking one example strictly after this, so you'll be understanding that one. And the rules are, for every I've considered any state Q1 comma A. In my case, I've considered the input symbol as A, so I've written currently at Q1 with input A, and then the transition will move to Q2. If you have such kind of transition in the given NFA, then what will be the production you'll be adding is this kind of production. Okay. And this in the production. And then M for Q1 belongs to set of final state, then add Q1 replaceable by epsilon in the production. Okay, this part I won't be explaining much for the time being, because if I have to explain you right now, it will be more complexify your concept. So better I'll take one example, and then with reference to that example, I'll explain everything very clearly. So let me begin with the example. Q naught Q1 This is Q2. Q3. Q0, Q1, Q2. E. E. This is NFA. B. C. C. Now, from this given example, from this given NFA, let me write certain things which will be required for our construction of grammar. Okay, and then let me write Q not command. No need to explain much, I guess. Whatever I have, whatever information I could gather from this NFA, I'm just listing it here. I'm just listing it here. Q not comma A, Q1. I guess no need to explain these things. Q is the set of states, so there are Q not Q1, Q2, Q3 I have written here. I could find from this given NF written it. Q naught is the initial state, so Q naught written the same. F is equal to only Q3 element is there, so Q3 is written here. The transition functions I have whatever retrieved from this particular machine, I have listed it here. Now, just now I have explained. Now, let me consider given M and F A is equal to Q summation Q naught this F, where delta is, let me just call it as A. Is A. Okay, this is the required information we have. Now, we are going to, our aim is to construct regular grammar, and then I've already told please mention the left linear or right linear. In my case it's going to be right linear, so I've written right linear. Then the required GRL is equal to NTPS. Okay, so grammar you need to fill this one, NTPS. In the previous points, what we have seen, N is nothing but is equal to Q is equal to Q naught comma Q1 comma Q2 comma Q3. And then T is nothing but summation, it is nothing but A comma B comma C. And then start symbol is nothing but initial state, so I've written it. Now here comes the production. And the production P is as follows. Now what I'll do, how many transition function I've written here? 1 up to 6. So every transition functions, right, I'll add in the production rules, applying the rules which I have just written it here. Okay, so now this production rule number 1 will be based on this particular one. So 1 will be converted to production 1, 2 will be transition function 2 will be converted to production 2. Likewise, I'll be numbering 1, 2, 3 like that. How many are there? 6. So let me number 1, 2, 3, 4, 5, and 6. Now, number 1, right? Number 1, let me write it here. Number 1 is nothing but delta Q naught comma A is Q naught. Now, as per the rules, here, delta Q1 comma A perform the transition from Q1 to Q2. Then how to add Q1 as the non-terminal on the left hand side, and then A followed by Q2 on the right hand side. So it's the same thing I'll be adding here. Here Q naught will be the non-terminal on the left hand side, and then A followed by Q naught on the right hand side. This Q naught, Q1, Q2, Q3 are nothing but non-terminal. Now what about 2? This is Q1. Let me just, instead of writing it separately, right, let me just copy paste. So it will save my time. Okay. Now see here, number 1 completed. Number 2, Q naught will be the Q naught will be the non-terminal on the left hand side, and then this A followed by Q1. A followed by Q1. Now number 3, right? Q1 will be the left hand side non-terminal. So let me write Q1, and then B followed by Q1. B followed by Q1. Now number 4, right? The left hand side non-terminal. B followed by Q2. Number 6, Q2, and then 3 followed by Q3. Now written 2 rules there. I have written 2 rules. Let me just write number 1 rules, number 2 rules. As per number 1 rules, whatever transition function we haven't uh, retrieved from the given NFA, right, I have converted to the production. Now for this particular rule number 2, whatever states in the set of final states you have, right, if you find any of the final states in your set of final state, then add this kind of production. So in our example, right, how many final states are there? Only single Q3. So for this Q3, right, another extra production that will be Q3 by epsilon. Okay, this is the required production. Now, let me just check. What kind of string is being accepted by this machine is AABC. This is being accepted. Or else ABCCC is being accepted. Or else ABBBC is being accepted. So it always ends with C. So let me just try to derive. Let me just try to derive a string of AABC using this particular production. So I have already told Q naught is the start symbol in this case. You have to start from Q naught. Let me start with A Q naught. Our target is to derive AABC from this particular given grammar. And then now Q naught. Again Q naught, right? Let me use Q naught because double E. And then next, what about Q naught? Q naught. Oh, sorry. We cannot directly replace Q naught by B. So what I'll be doing? This is using production rule number 1. This is using production rule number 2. And then AAQ1 is Q1 is 2 kind of there. Either BQ1 or BQ2. But once after this B, right, immediately we need to replace by C. So what I need to do is, instead of selecting number 3 or 4, I'll be selecting 4. So BQ2, this is 4. And then next one, AA. After this B, I need this C and then epsilon. So I'll be choosing 6. And then after this, AABC epsilon. This is 7. Hence, we have derived AABC from this. Okay, like this we need to check. So this is the end of today's topic. Now hold on a second. Soren Chui, absent. Bukesweta, absent. Harish Kumar Kundrakbam. Harish Kumar Kundrakbam, absent. Huidrom Abhishek Singh.
Yes, ma'am.
Okay. Kesab Kumar. Kesab Kumar, absent. Khwarakpam Nisita Devi, absent. Konsana Ganapati, absent. Niket Kumar Singh.
Present, ma'am.
Okay. Swamipam Chamroy.